Good evening, guys. Welcome, all of you. Very good evening. Yes, very welcome to everyone. Yes, guys, everyone can hear me properly. Please once confirm. We are going to start some really important reactions of organic chemistry. Yes, good evening. Good evening. Hello. Hi, welcome all. Okay, guys. See, in the previous session on reactive intermediates, we have discussed the reactions of benzene, right? Some really important previous year questions. And what are we going to do today? We are going to do the same reaction mostly for pyridine, because yesterday I told you that many questions are being asked on pyridine. So today I have taken pyridine and we'll try to focus and see more and more examples of pyridine and related compounds, right? And for getting regular updates for my classes, join the CSR Net 2022 group, okay, on Telegram, right? You will get all the class notifications on time. Very good evening to all. Chalo guys, let's start the discussion, right? And I have also told you that there were some really important questions which we have discussed in the plus classes, और वो फिर CSR Net 2020 एग्जाम में डायरेक्ट आ गया था, right? Just before few days we have discussed some examples, so we are going to do that as well based on this reaction mechanism. ठीक है? So first of all, let's see a very simple question. Question number one, guys, very simple. ये देखो, what is the property of pyridine? Pyridine की क्या property है? Let's say you have this molecule and you also have this very strong base. Yes, guys, what is this base? ETO whole twice diethyl carbonate. Okay. Yes. How is the product going to be? Yes, it's a very big base. Hexamethyl diacetyl azide, isn't it? LIHDMS. Right. What is this base going to do? So what is the property of pyridine, or what will be the property of this methyl which is connected to fourth position of pyridine, right? ये देखो, very important this mechanism is. So look over here, guys. In the presence of a base, this proton is going to be deprotonated, becomes CH2 minus. Why? Because if it becomes minus, the negative charge is going to go all the way down to nitrogen. This is a resonating structure and the molecule will be very stable, like this, isn't it? Or it can also, the negative charge can also do resonance into the cyanide, right? What happens next? Next you are going to have the diethyl carbonate molecule. So according to you guys, which center is going to attack on this carbon? Does nitrogen attack or does this carbon attack? कौन attack करेगा इस carbon के ऊपर? Yes, that is the question you have to answer. The nitrogen attacks directly like this, or the nitrogen is going to do resonance and this carbon is going to attack. Who will attack? Good evening, guys. Good evening, all who are joining now. Yes, absolutely, the carbon will attack because this carbon is also a soft center. So the bond opens up, it falls back, and one of the ethoxy eliminates. Your product is going to be something like this. It is pyridine, and the CH2 is going to directly attack on the carbonyl. So that is why you have got an ester. So this is your final product of the question. So what did we understand for the property of pyridine? That is, if a methyl group is attached to the fourth or the second position, guys, look over here. this molecule if a methyl is present on the second position or the fourth position or the sixth position, like this. 2, 4, 6. Any of these position, if a methyl is present, the proton is going to be acidic. Why? Because it can do all the way down resonance to nitrogen, and nitrogen is very happy with the negative charge, right? So all of these methyls which are present on 2, 4, 6 position will be having acidic proton. So this is one property that we got to know about pyridine. Let's look at another example. Yes. Question number 2, guys. Another way we are checking the property of pyridine is we are trying to make it do a electrophilic aromatic substitution. Yes, what is this? HNO3 H2SO4. What is the major product? Or you can tell me that nitration reaction, will it happen on pyridine or over benzene? किस पे होगा nitration reaction? Where is the nitration reaction going to take place? Yes, Sophia, nitration तो होगा, but where? On benzene or on pyridine? Absolutely benzene, guys, क्योंकि pyridine is electron deficient, benzene is more electron rich. Here we are doing a electrophilic aromatic substitution reaction. ठीक है, तो वो pyridine पे नहीं होगा, benzene पे होगा. But benzene पे कहाँ होगा? Ortho position, para or meta? That is another question. Yes, let's say if I'm writing it is going to be on benzene, but where? So pyridine is a deactivating group, isn't it? Pyridine is going to pull the electron density. So इसकी वजह से absolutely ortho और para तो नहीं होगा. It is going to be meta. So you are going to get the nitro on the meta position. So what is the property of pyridine that we understood in this example? Pyridine is deactivating and ortho para directing. Ortho para directing in nature. Meta directing in nature. And deactivating and meta directing in nature. Yes. All right. So this was another example where we can study one more property of pyridine. अब देखो question number 3. Let's say you have 2 chloro, 3 carboxylate substituted pyridine like this, and this pyridine is reacting with this molecule NH2 methyl on the second, chloro on the third. What is the reaction that you expect? क्या reaction होगा यहाँ पे? Yes. What is the reaction that you expect over here? Do you expect SNAR mechanism? ये देखो guys, pyridine on the second position. See, I told you when there are substituents on the second, fourth and sixth position of pyridine. Yes, no, Prince. The NH2 is not going to attack over ester. NH2 is going to attack on the second position of pyridine where there is a leaving group, isn't it? Cl is a better leaving group than ethoxy. इसीलिए ये नाइट्रोजन पे आ गया माइनस चार्ज. You have NH, one proton is lost, second methyl and third chloro. Okay, यस, फिर ये क्या होगा, ये यहाँ से बॉन्ड फॉल करेगा तो Cl माइनस इज गोइंग टू लीव. सो व्हाट इज योर फाइनल प्रोडक्ट? द फाइनल प्रोडक्ट इज गोइंग टू लुक समथिंग लाइक दिस. एस्टर इज एज इट इज. यहाँ पे हो गया है substitution NH and the molecule is same. This part of the molecule is same. What is this mechanism? SNAR mechanism. So pyridine के 2, 4 और 6 पोजीशन के ऊपर कभी भी कोई लीविंग ग्रुप प्रेजेंट हो, that is absolutely going to give you SNAR mechanism. Alright, this is one more important property of pyridine. Yes, guys, all of these examples that I'm discussing, you are going to write them in your plus notebook where we have studied the heterocyclic reaction, because these are all the good examples of the same. ठीक है, फिर हम चलेंगे फोर्थ एग्जाम्पल के ऊपर, फोर्थ क्वेश्चन के ऊपर. लुक एट दिस. All right, look at this molecule. What do we have, guys? ये देखो. This molecule, when I'm reacting with POCl3, all right, it gave me this molecule, 2-chloropyridine. तो ये क्या है, guys? What is the mechanism going happening through? क्या mechanism हो रही है यहाँ पे? Yes. With the POCl3, what kind of mechanism is taking place? And what do we call this molecule? इसको हम बोलते हैं 2-pyridone, because the double bond O is present on the second position, we call it 2-pyridone. So this is a specific property of pyridone to convert into chloropyridine by substitution. Yes, Prince, absolutely. ये ऑक्सीजन क्या है? ये लोन पेयर डोनेट करेगा फॉस्फोरस को, बट नॉट द लोन पेयर. नाइट्रोजन इज गोइंग टू यूज द लोन पेयर एंड द ऑक्सीजन विल अटैक दिस फॉस्फोरस. ठीक है, जिससे कि दिस बॉन्ड ओपन्स अप एंड इट फॉल्स बैक तो एक Cl माइनस यहाँ से निकल जाएगा. व्हाट डज हैपन नेक्स्ट? क्योंकि नाइट्रोजन ने डोनेट किया था इलेक्ट्रॉन पेयर, सो नाइट्रोजन हैज अ पॉजिटिव चार्ज नाउ. There's a phosphorus double bond O, 2 chlorines and 1 Cl minus and 1 Cl minus. Yes. Now this proton can easily fall off within the medium, within the solvent, and you are going to directly get pyridine with third position having the second position having this oxygen as a good leaving group. अभी oxygen भी good leaving group बन चुका है and the Cl minus is free. This Cl minus is going to do SNAR mechanism, substitution, addition elimination mechanism. OPOCl2 I'm writing directly, and this is 1 Cl, nitrogen पे minus है, falls back, and this time oxygen 1 is a good leaving group because phosphorus has a very high affinity for oxygen. तो ये वाला product मिलने वाला है phosphorus को, that is why it is very good leaving group. So you finally get 2-chloropyridine. This is SNAR mechanism. ठीक है, so यहाँ पे pyridine की क्या property पता चली? Pyridones can give you halogen substituted या 2-halopyridine in the presence of POCl3. This is how pyridones are going to become pyridine. Oxygen is a good leaving group over here. ये जो oxygen है इसका क्या काम हुआ guys? Oxygen was made a good leaving group and oxygen is left out with phosphorus, और क्योंकि एक Cl extra है so Cl got connected, right? Pyridones into substituted pyridines. Yes, isn't this a nice example? राइट. सो देर आर मैनी 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 गुड एग्जाम्पल्स ऑफ pyridine गाइज. अभी और भी एग्जाम्पल्स हम लोग देखने वाले हैं. द वन दैट आई टोल्ड यू दैट हैड कम डायरेक्टली इन द एग्जामिनेशन गाइज, वही डिस्कस करते हैं डायरेक्टली. यस, उसी को डिस्कस करते हैं. एंड बिफोर मूविंग ऑनवर्ड्स गाइज, लेट मी वंस अगेन रिमाइंड यू ऑल कि कल हमारा मॉक टेस्ट है, ऑल इंडिया स्कॉलरशिप टेस्ट. So what is a scholarship test? This is going to help you in getting an academy subscription at a very low cost. और जिसका first rank आ चुका है, that person is going to get an academy subscription for free. Okay, so that is very very important for all of you. For those who want to join an academy plus or for those who don't want to join, सबको ही ये test देना है to know your rank and to know your level, and you will get a all India rank also with compared with all the other students. Also guys, for those who have already joined plus courses, please enroll in this course which has recently started with between before 236 days. ये देखो, अक्टूबर 26 को स्टार्ट हुआ था, बेस्ड ऑन इनऑर्गेनिक केमिस्ट्री. कंप्लीट डिटेल्ड कोर्स ऑन इनऑर्गेनिक केमिस्ट्री, केमिकल बॉन्डिंग इज ऑलरेडी डन. ठीक है. यस, आपको नोटिफिकेशन आएगा प्रिंस उसका, आपने एनरोल किया है तो. यूजुअली मॉर्निंग में होते हैं टेस्ट. ओके, क्वेश्चन नंबर 5. दिस इज द मोस्ट इंपॉर्टेंट गाइज. ये देखो, लुक एट दिस. Now this is not pyridine, but I am discussing this example over here because as I told you कि this has been directly asked in the examination. And this is based on the synthesis of pyridine, not the reactions of pyridine. ये है chapter number 30 of Claydon aromatic heterocycles part 2. The question was directly asked on from the solution manual. ये देखो. चलो ठीक है, आई विल राइट द प्रोडक्ट्स ऑल्सो फॉर ऑल ऑफ यू बिकॉज ये सिंथेसिस बेस्ड क्वेश्चन है. सो वी विल जस्ट थिंक अबाउट राइटिंग द मैकेनिज्म. बाकी हम प्रोडक्ट को ही देख लेते हैं, हाउ इट हैज बीन फॉर्म्ड. ओके, सो लुक एट दिस प्रोडक्ट. द वन मॉलिक्यूल दैट यू हैव, अमीनो कीटोन. This molecule in the presence of acid with this ketone gives you pyridine like this. The same molecule, the same ketone in the presence of base gives you another isomer of pyridine. ये देखो guys, ये क्या हो गया है, ये pyridine का isomer बन गया है अभी यहाँ पे. This is an isomer of pyridine. So why is this happening? You had this question in 2020 examination कि ये ऐसा क्यों है? Which one is the thermodynamic product? Which one is the kinetic product? That also you had to write. Okay. So let's say we are going to draw the mechanism that how is this happening. This is the question from chapter 30 Claydon solution manual. Okay. You can check it out over there. Chalo. So we are going to discuss guys why is this reaction happening, giving you two different products in different medium. देखो, so first of all guys, मैंने आपको क्या बताया था, whenever you see amine and a carbonyl, you are first of all, without any second thought, first of all you are going to form the imine. Yes or no? ये नाइट्रोजन है, प्राइमरी अमीन है, और ये कार्बोनिल है, इससे क्या बन जाएगा, इमीन बन जाएगा. Like this. This is the imine that you have. Imine. Okay. लेकिन guys, क्योंकि synthesis हो रहा है, so imine से enamine बनाना पड़ेगा. We have to make the enamine. So in the presence of acid, we will try to remove the proton and give you the more substituted enamine. That is the real reason that why you are having two different products over here. Very beautiful question this is guys. ये देखो, ये सिंगल बॉन्ड हो गया, ये डबल बॉन्ड हो गया, एक मिथाइल इधर, एक मिथाइल इधर. तो ये इनामीन क्या है गाइस? दिस इज अ मोर सब्स्टिट्यूटेड इनामीन. मोर सब्स्टिट्यूटेड इनामीन. isn't it? और जो more substituted enamine होता है, that is the thermodynamic enamine. What is thermodynamic? More stable actually. Thermodynamic intermediate. All right. The second possibility is if we are taking a base. Base will not think about which is a stable or unstable enamine. Base is going to just remove the most readily available proton. तो सबसे ज्यादा readily available कौन सा proton है? ये वाला. So base ने क्या किया? Base ने इस proton को remove कर दिया. Like this. There is a nitrogen, single bond, double bond over here और ये ethyl as it is. This is your hydrogen. So this is another enamine, लेकिन ये तो kinetic enamine बन गया. This is a kinetic enamine now. All right. Now we have drawn the intermediate. We have drawn both the enamines which are possible. अब हम इसी से product बनाएंगे. Okay. What are we going to do? Let's say look at this. Thermodynamic enamine को देखो. यहाँ से हमने attack करवाया है on this carbonyl oxygen. You are going to first of all get something like this. PH, OH, N, double bond, one single bond and one more bond. तो ये क्या हो गए? दोनों मिथाइल इधर आ गए. Right? You got this point, guys, that there will be a hydrogen. Nitrogen has a positive charge. Okay, अब यहाँ से ये product बनाना तो मुश्किल नहीं है. Just a loss of water in the presence of acid will give you this product. Okay? So this is the enamine that we have formed. That gives you this product. However, ये जो kinetic enamine है guys, इसको हम करेंगे redraw because we need to write the double bond over here. Let's look at this. NH. We need to write the double bond over here because we have to make the attack, right? So in the presence of a base OH minus, the proton is eliminated and the double bond attacks over this carbonyl. The bond opens up, right? So you are going to have this kind of a molecule. ये देखो, one pH, one OH, one nitrogen, double bond, single bond like this, और ये ethyl group आ गया यहाँ पे. So once again the loss of water will give you this product, this pyridine. So this is a question on synthesis. Synthesis में ज़्यादातर आपको enamine बनाना पड़ता है. Now the question is based on two isomeric enamines. ये इसीलिए बहुत ज़्यादा अच्छा question है because it is based on isomeric enamines which is going to give you two different quinoline molecules. What are these molecules, guys? ये तो quinoline molecule है. Just one pyridine ring is forming. Benzene is already there. ठीक है? So very very important synthesis method, right? So this is a question directly from the solution manual. जो आप लोग पढ़ रहे हो अगर तो बहुत अच्छी बात है. Chapter 29 and Chapter 30. Both the questions you have to do the practice. ये मैंने आपको Chapter 30 से करवाया है ये question. Okay? All right. Okay, guys. So this is it. We have done 5 important questions on the reactions of pyridine. आज हम और एक YouTube session कर लेते but क्योंकि 8 बजे एक special class है, right? At 8 p.m. we have a special class today, just after 1 hour, where we are going to be discussing all the important organic questions for your revision. ठीक है? All the important organic previous year question ताकि आपकी revision हो जाए so that you are able to give the mock test nicely. All right, All India Scholarship Test. Okay, so now I'm going to see you all at 8 p.m. on Unacademy, and the link for the class will be shared on the Telegram group. ठीक है? और कल मैंने आपको बताया है कल आपका scholarship test है. So give the scholarship test and get the chance to get an Academy Plus subscription for the minimal amount. Okay, and if you are interested in joining Plus, you can join up using code Jagriti S Live as well. Okay, So I'm going to see you all after 1 hour, guys, on an academy. See you very, very soon. This was a short discussion session. And yes, guys, whenever you have time, study chapter 30 and chapter 29 and 30. These two chapters, okay, based on pyridine's properties. All right, guys. Chalo. Bye, everyone. Take care of you.